Hello everyone, welcome to the Transformations unit. As we begin this unit, let's take a look at our first lesson, which is all about horizontal and vertical translations. We're going to be doing this lesson as well as the second lesson for homework tonight. Okay, so in this unit, we're going to look at developing an understanding of the effects of transformations. Operations are which move or map a figure from an original position to a new position on the graphs of functions and their related equations. The transformations we're going to look at are translations, reflections, and stretches, or any combinations of these. In particular, we will consider replacements for x and or y in the function y equals f of x and investigate how the function, now you need to correct this in your workbook. We're going to get rid of the minus k part because they actually put the plus k on this side. So it is y equals a f bracket b bracket x minus h n bracket plus k. And this formula is on your formula sheet. Okay, in case you forget that. So that's on your formula sheet. And we're going to look at how that is related to y equals f of x. Now, all these parameters, a, b, h, and k, we're going to be learning about. And in particular, in this lesson today, we're going to be looking at h and k. Okay, so our first topic is translations. Translations are simply a transformation that slide each point on a figure the same distance in the same direction. So that's maybe, we're going to look at horizontal, so moving it left and right, and vertical, moving it up or down. So let's look at a little investigation today. So we're going to compare the graphs of the original y equals f of x here and y minus k equals f of x, or if you add k to the other side, it could be in that form as well. This one is a little clearer and it will make more sense when we go to do the horizontal translations as well. Okay, so we have a table of values for y equals x squared. So when x is negative 3 squared, we get 9. X is negative 2 squared, we get 4. Okay, so what we're going to do with this next second table is we're going to figure out the y values if our equation now is y minus 3 equals x squared. So just so it's a little bit easier for us to calculate y in this table, we're going to add 3 to both sides just to remove that a minute. So really what we're doing then is we're taking our x squared plus 3. So here's our x squared, y equals x squared function. So really negative 3 squared, 9, plus 3 is going to be 12. Negative 2 squared is 4, plus 3 is 7. Noticing a pattern yet over here? Let's try the negative 1. Negative 1 squared is positive 1, plus 3 is 4. Looks like all these y values seem to be increasing by 3 compared to the first table, which makes sense, x squared plus 3. So that means our next one should equal 3, and then 4, and then 7, and finally 12. Okay, let's look at this equation. Y plus 3 equals x squared. Okay, again, we're going to just move that 3 over so that we can calculate these y values. Okay, so x squared minus 3, so negative 3 squared, 9, minus 3 is 6. Negative 2 squared, 4, minus 3 is 1. Negative 1 squared, 1 minus 3 is negative 4. Wait, did that one wrong. Negative 1 squared is 1, minus 3 is negative 2. There we go. Let's compare to the first table. 9 went to 6, 4 to 1, 1 to negative 2. Looks like it's all negative 3 or minus 3 from the original. Okay, so that would make each of these those values there. And there we go. Okay, use the table of values in A to graph and label each of the functions on the grid. So this is where you're going to pause the video and I am going to graph this first or the second table in blue on this grid, and then I'll do the second one in red. So you grab your different colored pens as well and we'll see if we get the same answer. Okay, pause the video. Okay, so did we get the same graph? the blue function looks like it's above the original black function here, and the red function is below the original black function. And I've labeled the equations as well with the original form of them, not what I needed to do to figure out the table of values. Now let's see if we can answer part C. In the second table, that's this one here, y has been replaced with y minus 3. Let's just take a look at that. Okay, so compare, notice no longer y, now it's y minus 3. What is the effect of this replacement on the graph of y equals x squared? Okay, well, going from that black graph to the blue graph, it looks like every point on that graph got moved up 3 units. Okay, so what is the effect on the replacement of the graph? Moved graph up 3 units. Okay, in the third table, y has been replaced by y plus 3. Let's take a look at that. Okay, so compare original to this. What's different? Y is now y plus 3. So, and that was the red graph, and that one, the graph moved down 3 units. Okay, so that's interesting, eh? Y plus 3 moved down 3 units. Y minus 3 moved up 3 units. Kind of opposite of what you would think, right? Okay, let's take a look at the next page. Okay, part 2. We're going to use the graphing calculator on this one, and it asks us first of all to use the graphing calculator to graph the following functions. So y equals the absolute value of x. Remember where to find absolute value. That's found under math, num, and then abs, and then you come back to the graph and you put in there, you'll put x. Okay, so you go ahead and pause the video and grab your graphing calculator, put that in, and then let's sketch that graph onto these grids. And we'll do it for all 3, and then we'll talk, okay? So pause the video. Okay, so we've got these graphs plotted here. It doesn't have to be a perfect graph, but the things you should note is, first of all, the absolute value function. We've got that V shape happening again. Vertex on the original, y equals absolute value of x, is at 0, 0. Then we graphed y equals the absolute value of x plus 2, and our vertex is now at 2. And when we graphed y equals the absolute value of x minus 3, our vertex moved down to negative 3. Okay, now let's look at this equation in a slightly different form. That positive 2 on the right-hand side, that could be moved over to the other side by subtracting it from both sides, and we would get this equation here. Now, if you'll notice, if we compare to the original absolute value function then, this new one, what's happened is we've replaced y with y minus 2. So how does the replacement of y minus 2 affect the graph? That would be this graph here. Looks like it moved up 2. Moved up 2 units. Okay, now the next one, y equals absolute value of x minus 3. Again, we can add 3 to the other side, so our equation looks like this. Comparing, y must have been replaced then with y plus 3, and we get this graph here, and our graph moved down 3 units. Okay, moved down 3 units. That's pretty consistent with what we saw in the first part of our investigation. So using the results, in general, I guess what we can conclude from this is if we have a parameter k and it's, well, let's do this one first, y minus k. It pretty much was opposite of what you thought. When it was y plus 3, it moved down 3. So when it's y minus k, it moves down, sorry, that's minus, so that would have been moving up, opposite of what you think, up 3 units, right? Minus, you'd think it was moving down, but it's opposite of what you think, so y minus k would move up, not 3, up k units. All right, or if we move that k to the other side, then it would still be the same translation. It would be up k units. So in other words, when the k is with the y, it works backwards, right? when it's over here not with the y, it works normally. Plus k, it moves up k. All right, so in general, complete the following statements. Compared to the graph of y equals f of x, the graph of y minus k, so you'll notice y was replaced with y minus k, results in a, now they're looking for the word either vertical or horizontal here. So y is a vertical parameter. And so if we mess with it, we are basically doing something in the vertical direction. So vertical translation of k units. If k is greater than 0, so that would mean y, and then minus is still there, k is greater than 0, so say something like 3, the graph moves up. If k was less than 0, so we would have like y minus, and then k is like -1, that would become then y plus 1, and the graph would move, opposite of what you think, down, right? Y plus 1. Okay. So this notation of y minus k equals f of x is often used instead of y equals f of x plus k to emphasize that this is a transformation on y. When it's with the y, it's a transformation on y. And that's going to be an important concept later as well. Okay, let's look at the next page. Okay, now we're going to look at the graphs of y equals f of x, original graph, and y equals f at x minus h. So now we're replacing x with x minus h. So let's take a look at this. We have our table of values again for our y equals x squared, and then we are going to fill in the table of values for y equals x minus 3 in brackets squared. Okay, so let's try -1 in there. -1 minus 3 is -4. -4 squared is going to be +16. And 0 minus 3 is going to be -3, squared is 9. Okay, you guys fill in the rest of those. Pause your video and we'll see if we get the same answer. Okay, so we filled those in. We should have gotten 16, 9, 4, 1, 0, 1, 4, 9, 16. Did you guys notice when you filled both of those table of values in, we ended up with these original y values? Well, that's interesting. How can we get the same y values? Let's compare the x values. So for the first table, we have x values of -4 for that first one, and here -1. So basically 3 more, right? -3 versus 0. Again, 3 more. So what they did was they changed all the x values. They do that here as well? Yes, they did. Look at that. They subtracted 3 from all those. Okay, well, that'll be interesting. Let's do part B. Use the table of values to graph each of the functions. Okay, so you're going to graph them as well. Again, I'm going to do this graph here in blue and the other one in red, and then we'll compare to see if we have the same graphs. Pause your video. Okay, so we've graphed these, we've labeled each line, and the blue graph is our second table, which is y equals x minus 3 squared, and our red graph, the third table, y equals x plus 3 in brackets squared. Okay, let's answer C and D. In the second table, x has been replaced with x minus 3. See that? Instead of x, we now have x minus 3 inside the squared function. What is the effect of this replacement on the graph? Well, from the black graph to the blue graph, it looks like it moved 1, 2, 3 units to the right. So, moved or translated 3 units right. Okay, in the third table, x was replaced with x plus 3. And that graph is our red graph. From the black to the red, it moved 1, 2, 3, moved or translated 3 units left. That seems to be opposite again, doesn't it? X plus 3 moved left in the negative direction, and x minus 3 moved right in the positive direction. Okay, we're going to continue this on the next video, part 2, so we will see you there.